Today we are learning how to balance chemical reactions. We need to learn this so that we can determine the different amounts of chemicals required for reactions to take place. And our success criteria is being able to balance an unbalanced chemical reaction. So when we balance chemical reactions, we can represent them in simplest form, simply as words. We can say hydrogen and oxygen react to produce water. This is good at describing what's involved, but it actually provides very limited information. It doesn't tell us the chemical composition of any of the substances present, and it doesn't tell us the number of atoms or the number of molecules present either. We can give a bit more information by writing a skeleton equation, which is an unbalanced reaction. We can say H2 plus O2 reacts to become H2O. This does provide us with more information. It tells us what the composition of each molecule is, but it doesn't tell us a critical piece of information, and that's how much hydrogen and how much oxygen is required for this reaction to take place and how much water is going to be produced. So, what we have to do is we have to balance this unbalanced reaction. Balancing takes some practice, but it's actually pretty simple once you get the sequence down. So, first thing we're always going to do is we're going to have to start with a skeleton equation. We need to be able to write out the correct formulas for each compound. After that, we're going to count the number of each atom or polyatomic ion in the reactants and the number of each atom in the products as well. And what we're going to do is we're going to compare those two numbers to each other. If we see something is unbalanced, we can multiply an atom to make the numbers equal on both the reactants and the product sides. Most of the time, we're just going to use multiplication when balancing reactions. Sometimes we do need to use a bit of addition, which I will show you in the sample problems, but 90% of the time we just stick with multiplication. Whenever we multiply to make sure that the number of atoms is balanced on each side, we also have to take the number we multiply by and stick it up top into the skeleton equation. This is going to be the number in front of the formula, which we call the coefficient. If we stick a coefficient in front of a formula that is a compound that has more than one type of atom in it, we also have to multiply those other atoms by the same number. So what you'll see is that as you shift one number, it's going to adjust it and start changing other numbers as well. And we're just going to follow that pattern, adjusting the numbers as we go until everything is balanced. And we're going to make sure that we're careful not to unbalance anything throughout that process. So going back to our previous skeleton equation, which I'll also show you in a sample problem too, we can balance the combustion of hydrogen using a couple of numbers. We can see right away that we have 2 hydrogens in the reactants and 2 hydrogens in the products, so those are balanced, but the oxygens aren't. There's only 1 oxygen in the products, but there's 2 oxygens in the reactants. So we're going to write a coefficient 2 in front of the water molecule. That doubles the number of oxygens, but it also doubles the number of hydrogens. The oxygens are balanced, but the hydrogens aren't anymore. That's okay though. There's 4 hydrogens now, but we can also multiply the H2 to bring it up to 4. So if we add a second coefficient, so we have 2 H2 plus 1 O2 becoming 2 H2O, that is a balanced equation. And you'll note as well, we did not write the 1 in. If there's no number, it just implies there's a single copy of that particular substance.